Okay, well, welcome everyone. And my name is Star, and I am one of the member of the KubeVela team. And today's community meeting, we have two major agenda. One is the introduction for the integration with BackStage, which will be introduced by Jianbo. And another thing is that I will going to introduce some preview of the new features, which is the control plane sharding that we will like to release in KubeVela version 1.8, which might be like 1 or 2 months later. But we have some alpha version released. So if you are interested in it, you can try it. Okay. So, and another interesting we would like to say is that recently we have been processing with the CNCF with the incubation project proposal, and it seems that the CNCF has passed the proposal. So actually, KubeVela is going to be a CNCF incubation project, I think in a few days. So I think that's a big progress for the community, and thanks everyone for the contribution and participate in the building of this community. Okay, so. Okay, I see that Jianbo sends a message in the chat box, and if anyone is interested in that, you can click in it and see more details. Okay, so I think let's start with the first agenda today, which is the introduction for the BackStage integration. Jianbo, are you okay to share with your screen?
Okay, thanks, Da. I will share my screen.
Okay.
Yes, I have just posted the link of the CNCF vote procedure, and the KubeVela project is still in the vote process, but the majority of the CNCF TOC has passed, has vote for the KubeVela project. If you are also interested in the KubeVela project, we hope you can help us to vote with a non-binding vote. That's a sign of support. And today I will share you the BackStage plugin, the add-on. This is an experimental add-on that, but you can try it, and it's already have an end-to-end doc. First, let's see the architecture of the add-on. The add-on, the metadata of the add-on is contained in the catalog repo. So it can be installed as a KubeVela add-on with just 2 lines of commands, and then you can vet this add-on by Vela port forward. And here are 2 repos that contains the images. One repo is a BackStage plugin, and one is a BackStage app. The architecture is like this. And when we running KubeVela in the Kubernetes control plane, we will have several KubeVela apps, and through the BackStage plugin Vela, it's a Go project. Actually, it's a proxy, and the proxy will convert the KubeVela applications, components, and traits into BackStage catalog, and these catalog will convert to different entities. Some of them are BackStage service, BackStage components. Some of them are BackStage system, and some of them are other entities. So in the in the BackStage experimental add-on, we will install the BackStage plugin Vela, and also with a BackStage front-end app. The BackStage front-end app is just generated by the BackStage command line. I think the BackStage is currently very popular in the cloud native community. So I just use very I just write the guide about how to create the BackStage application and how I use this add-on. In your use case, you can also follow these changes and change your own BackStage application. First, if we do nothing, when we have installed the BackStage add-on, we can just get the BackStage page. The BackStage page will sync the KubeVela applications as different entities. Some of them are components. So by default, the KubeVela applications will have will convert it, any application will convert it as a BackStage system. So you can see there are these are all KubeVela applications, and the prefix is a namespace, and here is a Vela application name, and this is a BackStage add-on. It's also a Vela application, so it automatically converted as a BackStage system, and it has two components. These two components, one is the BackStage front end, and this is also the service we are visiting, and another is a proxy. This is a Go server. It's just a convert Vela application custom resource from Kubernetes API to BackStage API, so that we can visit it through the BackStage app. And so in this example, we can see the BackStage, the BackStage component is aligned with the Vela component. This is a basic case that we don't need to do anything. The KubeVela application will automatically convert it. And when we want to use some more features, such as we hope to assign the application user and have an alias name, and other features such as add some BackStage group, BackStage, and specify a BackStage system, we can use the trait or annotation. In the BackStage add-on, we will convert the annotation as BackStage information. So we have added several annotations. When we add these annotations, for example, when we add the BackStage OAM.dev owner and the application, which is the first Vela application, will has the owner. And we can also specify the domain, the description, the title, and tags. And we also add a trait in the add-on. With the help of this trait, we can specify the information for this component. For example, this component is the Express server. Then when we assign this trait, we can name the type of the BackStage component it converted, the lifecycle, the owner, and the description, and other information. So let's see the example that I have added this information. this is the first Vela app. So I have add more information on this example. So the example we have just solved is a bit less. So let's see. When we have added that annotation, we can see the BackStage component has a title hello world, and we have also added the notation. Let me open the example, the real example for you. The real example is in the BackStage plugin KubeVela repo, and it's here app.yaml, and I have added this trait. So in this trait, we have added the user. The owner is Wonderflow, so we can see the owner is here, and we also have the owner information as the in other entities. We have the user information here. This describes the user information, and we have a trait. We have a trait called a BackStage location. When we use this trait, we will convert these links, these user information and other BackStage entities into the system, so we can get all these informations. So we can have a very fully very detailed information about what's the owner of this component and what's the system of this Vela app. And also these are some links in the trait that we can check the source code of this app and the other links. And the most important is we can check the relationship of these component service and the maintainers and see these informations. The BackStage also has some features such as we can see the API of the system. The mechanism is the same. That I also add the BackStage API information in this trait. So when we open this information, it's actually this file, this API file. In this API file, I have added the API doc here, so we can check the API here, get the definition of this API, and learn the details. This is a Swagger plugin. These features are all BackStage that we can just integrate it with KubeVela. So so what do you need to do to integrate the BackStage Vela plugin with your own BackStage app? I also add the docs. You can just check the docs here to learn how to build your own BackStage app, and the changes are very simple. You can just see the changes in the pull requests. This is a Docker file to tell you how to build the Docker image from BackStage app to the image that can be deployed in the Kubernetes system. And the second pull request is how to integrate the KubeVela add-on. Some the main code is here. It's if you are using BackStage, I think you must learn the TypeScript well. You just need to add the Vela code as a custom provider here and add it in the catalog process. And it will actually read the proxy and gets the entity from the API. And convert it as a BackStage catalog, a BackStage entity. Yeah. That's all for my demo. I think you can experience it. And if you have any issues, you can just ask in the Slack channel.
Okay, thanks, Jianbo. And let's see if there is any questions for the BackStage integration. And I think BackStage can be a great tool for managing the asset owners and some basic information for the no matter the applications or the Kubernetes native resources. And Jianbo, I have a small question for that. So I see that there is some BackStage resources like the user and API. Are these resources that needs to be applied in the Kubernetes cluster?
No, that's all links. We just need to use a BackStage location trait, and in the trait we can define the links.
Okay.
And the plugin will convert these links, read it, and proxy it as BackStage entities.
I see. So they just reuse the Kubernetes YAML format for describing those data.
Yes, they don't even stored in the etcd database.
I see.
They are not exist actually.
Cool, thank you. And okay, I will go on with the second agenda today. And if there is any questions, that's you can raise it in the Slack channel or the chat box as well. And we will later look into that. Okay, so let's go start with the second agenda, and I will share my screen. Okay, can you hear my screen now?
Yes.
Okay, cool. So my sharing today for the second agenda is about a new feature preview, which we would like to release in Kubernetes version 1.8, and that is the control plan sharding. So this feature is mainly about dividing your KubeVela core controller into multiple parts for handling different applications. And we have seen that there are different cases that could be used with this feature. For example, if you have a very large system that you use KubeVela to manage multi-tenant applications, or you have a huge amount of applications that need to be run, but the single application controller could be risky to handle all the applications. For example, if there is too much application, the controller might be blocked and the performance might be bad. So all the application handling process will be blocked. So if you can divide your applications into different groups, like for some tenants, they will use controller 1, and the other tenants will use the controller 2, so that they will not affect with each other, and the damage of each controller will be minimalized. And also, it would be easy for you to scale up with the control plan. Because you can just add more shards to the controller to let more applications to be handled. and that will not need you to restart existing application controller. So that's what application controller sharding that you can do. And here is a very simple architecture for the overall design. And you can see that previously we only have one Vela core. And you can see that there are lots of controllers inside, including the component definition, the application mutating webhook, the application controller, and many other things. And we all bundle them in one container image. So when you run KubeVela, there is a very unified controller you will use to manage all the applications previously. But if you enable the sharding mode in version 1.8, and you will be able to add more shards of application controller into your system and let them to handle different shards of your applications. For example, when someone creates a new application, an automatic scheduler will assign a shard for the application, and the corresponding shard will handle that application, and the other application controller will not be notified with that. So that means only the application controller that manages the corresponding shard will use its computation resources to handle that application. And if this controller breaks, then only the applications that belongs to this shard will be affected, but other applications will not. And also the scheduling part can be also customized, and currently we implemented it into a application mutating webhook. So by default, if you enable the sharding feature, and an automatic scheduler will be used, and it uses round robin to assign applications averagely. But you can also make your customized rules if you would like to assign different you have different sharding assignment strategy, and you can just make up your own scheduler for that. And that will be very easy because you only need to set up a single label for the application, and all the mechanism will just work. So let's see some example. And I have already prepared with a cluster. And this cluster, we can see that in the Vela system namespace, we have enabled lots of things. For example, usually we can see the deployment first. So the default thing is that we will install the KubeVela Vela core deployment, which will represent the Vela core controller in master mode. And there are some other deployment. You can see that there is shard 0, shard 1, and shard 2, and they are joined into the cluster. And you can easily with that by using the Vela add-on enable command, and you can set the shards you would like to use. And this will give you a copy of the master mode controller, and all the controller will just use the same configuration. But if in some case you would like to have different shards have different settings, for example, you want to let the shard 0 to use some special feature gates, and it will be possible to to make customization for the configuration of this shards controller. And you just need to edit the parameters inside this deployment. And for the demo case, I will just use all the controllers use the same settings. And we already have some applications in the Vela system namespace, which are some pre-installed add-ons, and they are mainly for the observability. Because if you use multiple shards, the most usual case is that you have a lot of applications to handle. So the observation will be critical for you to see how the system runs. So let's see, there is a Grafana. And in the Grafana page, and you can see that the KubeVela system will show that now we have 6 applications, and the 6 applications are assigned to the master shard, and other shard has no applications for now. And there are memory use and the CPU use. So if you find out some controller might running with high load, you will see that some of the ports will have high memory use or CPU use. So in that case, you can like to adjust your scheduling strategy or let other shards to handle more applications. And here is the overall stats for the applications. But it is also possible for you to like to go inside. For example, you can go to the Shard1's controller and see how it goes with the controller details, like the queue for the controller, and it will be very useful for you to debug and to diagnose how this system works. And okay, so now we have a existing system that run multiple shards. So let's see what will happen if we apply some applications. Okay, so let's see. There is some very simple application here, and let's rename it. Okay, so this is a very simple application. Let's say we use with username test app, and it will run a Nginx container, and we just need to apply this application to the system as usual. So there's nothing special you need to do for that. Okay, I think yeah, so it works now. And okay, so let's see how this application, okay, so the application now is running workflow. And if we go inside with this application, we can see that there is a label. Okay, so I think there is a label that is attached to the application, which means this application is currently handled by the Shard0 controller. And if you go into the logs of the controller, you will see that only the Shard1's controller will handle the application. Okay, so you can see that it is currently handling this application. I think the log is outdated. It has lots of logs here. So we just go over this, go to this page, and you can see that from the Grafana page, you can see that the Shard0 now currently have 1 apps, and it is assigned to this shard. Okay, so if you are very interested in how this assignment is dispatched, and we can just make some let's make some experiments like to create 100 application. It might need some time. So it's just a mock. So there is lots of applications are currently being dispatched in the cluster, and we can check those applications here. Yeah, so they are running now. And let's say if we go to the app3, and let's check the label here. And this one is scheduled into the master shard. Okay, so if we go to the Grafana page and see the metrics here, so the metrics collected by the Prometheus will have some small latency, but we can gradually see that the applications are being created and assigned to different shards. So by with round robin algorithm, the most usual case is that those applications are scheduled evenly to all the shards. So later you will find that these shards will have very similar application numbers. Yeah, but because different shards will have different metrics collection, so the speed of the increase of this application might have different numbers for now, but finally they will reach the same number. Okay, so we will just wait and see that. And if there is also some, okay, so there is also some details for the application, other applications. For example, you can go inside the application page and see these applications. Okay, so I use a very simple mock application which only dispatch a deployment, a secret, and a config map. Okay, so this is a very simple use case for your a showcase for the multiple shards of your system. And if you are interested, as I have just mentioned, if you are interested in the details of one single shard, you can just pick out the pod and see how the controller metrics are changing. And it will be useful to diagnose if something breaks. Okay, so here is a very brief introduction. And there is also some, as you can see, we just have a test app application. And if I remember it correctly, it is currently assigned to the shard 0. So in the case that, for example, if shard 0 is broken and the pod cannot restart, and you might have the case that you want to migrate those applications in shard 0 to other shards. You can use the Vela up command. Like you can use Vela up, the app's name, and use the shard ID. Let's make it to shard 0. Okay, with this simple command, you will see that the application now, the test app now is still running and everything works fine, but it is now rescheduled. I think I use the shard 0. It's the same one. So let's move it to shard 1. Sorry. Okay, so the develop command, when it migrates the application to other shards, it will not only migrate the application itself, it will also migrate the related system resources, including the application revision and the resource tracker. So these migration are used to ensure that so only the corresponding shard of application resource will be cached in that controller. So so although you have multiple controller, each controller will have will do not have cache for the applications in other shards. So the memory use will be minimalized in each shard of controller. Okay, so you can see that the test app now is rescheduled to the shard 1. Okay, so that's a very brief demo for the control plane sharding feature, and the version 1.8 alpha 0.1 version has been released. I think today we have just released that. So if you are interested in it, you can just try it, and the installation is very simple. You just need to set up with the sharding.enabled equals true. So, and you can make upgrades on your existing system as well. It's okay with that. And I think later in the future we would like to make some load tests on the multi-cluster cases, so that we can see how the authentication, the sharding, and the multi-cluster, how these features can be combined together to solve large-scale problems, especially in multi-tenancy environment. Okay, so that's all for my sharing today. And I see that there are message. Okay. Is there any questions for the features we introduced today?
Hey, Diane, just a quick check on your suggestion. At what point of a number of applications should we think about using sharding? Is there some sort of heuristics that you've come up with, or any recommendation on if you are about, I don't know, say 1,000 apps, consider using sharding or something like that?
Yeah, so I think previously we have done some load tests, but that will be 1 year ago. So it depends on the size of your application. So for example, previously we have the application that manage like we have application in the load test that have like 5 to 6 resources, but we have seen that there are cases in the community that someone might use the multi-cluster delivery. So each one application could like to dispatch like 50 or 100 resources into the cluster. So the application size could vary a lot. And so the number I will mention below is based on each application will have 5 to 6 resource. So if your application is much larger with that, you can just like to divide the number I will mention later. So in the load testing before, for applications that carries like 5 to 6 resource, the default parameter in the installation of KubeVela could support around 2,000 to 3,000 application. So it's like you have very minimalized the resource for the controller, and you can have around 2,000 applications, small applications in your cluster. But if you give lots of resource to the controller, for example, if you have 2-core CPU and 4 gigabytes memory for the application controller, I think that would be okay to run 5,000 to 6,000 applications. But there might have some points that some of your application might have abnormal cases, and the most best case is that those bad applications will block the controller for some time. So the handling of other applications, although they could be handled, but they could be delayed for a while. It is possible to face that problem. And also in large scale cases, because previously we do not have sharding, so to support large scale cases, we have some fine-tuning strategies. For example, you can close some feature flags. For example, you can disable the revisioning of application to let your application controller handle more applications faster. But that would be some more optimization details. But with sharding, you can just have more customized scaling strategy for that. For example, if you have 2-core and 4 gigabytes memory, you can like to divide it into 4 small controllers and let them to handle different shards of applications. And I think it is especially useful if you have a very clear different category of applications that need to handle. For example, in multi-tenancy cases, divide applications depending on the tenancy would be a very nature choice for you to make the sharding parts. And but if you think that handling all the applications, like you only have like 500 or 600 small applications, I think you do not need to use the sharding. You just use 1 core controller is enough.
Well, thank you,
yes.
Dan. I have one more question, just to add, because if you'll be adding more controllers, is the pressure on the HCD or anything on the Kubernetes control plane of a concern that we should be thinking?
Yeah, so we have considered that problem because it is true that the bottleneck we faces in the previous load testing is most about the etcd storage and the Kubernetes API servers request burden, because KubeVela application, most cases they are dispatching all kinds of resources and they are interacting with the Kubernetes API server. So these 2 parts are the most possible bottleneck for the application controller. But in the sharding cases, we have ensured that the caching of the application and also related resources such as resource tracker and application revision are divided into different parts. So I think the storage used by the etcd will not have significant increase in sharding, or you make only one shard with a total of all the resources. So I think if you have limited resources and you make different shards or use one shard, the pressure on the etcd will not change a lot, and I think there is no much increase for that. So in that case, if the bottleneck happens to the etcd part, I think sharding itself cannot handle the case. But we are actually planning to do some storage recover features after the sharding part, so that it could probably be used if the etcd crash, and you can have backup and restart it on other control plane. And another choice is that in community, I have seen that there are some cases that they are trying to replace the etcd with other databases such as MySQL or MongoDB. And although KubeVela currently we do not have the existing feature for that, but if there is this is a case for some production use case, we can make some investigation and try if there is any practical path to those usage.
Cool, thank you.
And yeah, thanks, Inda. I also want to add some information about the how to measure the applications that your cluster can handle. That we already add the observability add-on. When you install that add-on, you can see the system dashboard, the Vela system. The Vela system dashboard will show you 3 dimensions. One is the CPU percentage. It's about how many CPU have you used of the Vela core. When the CPU percentage reaches 100%, it means you must larger the CPU limit, or you can use the sharding feature. The second dimension is the memory, and the memory limit is just according to your applications. When your application has lots of resources, one application will generate app revision and the resource tracker to track all these resources changes. And so the number of applications also multiples the memory limit. So you better check the memory limit when the memory has reached the limit. It will cause the OAM failure. And so it's also a very important dimension. And the second dimension is latency. That means we have the reconcile loop in the Kubernetes control plane. So Vela will reconcile periodically in about a configured time. By default, I think it's 5 minutes. So every application will reconcile once every 5 minutes. So when the latency larger, you also need the sharding feature to make all these applications are reconciled in different pods. So the latency will reduce. So you'd better not remember any fixed number of the applications. You just remember these 3 dimensions and check the dashboard for your own. That can help you to learn your system better. And as to say the Kubernetes pressure in our practices, sometimes the bottleneck will come from the API server. It's true. Actually, when the application is very large, and there will create very lots of application revisions and resource trackers, and any list API request will cause a very long time request to the Kubernetes API, and it will cause the Kubernetes API server to become very slow. So we also developed some feature flags such as ZSTD to compress the size of the resource tracker and the application revision. You might add that, turn on that feature flag. So the sharding feature is also a good start that we can scheduling the application in the mutating webhook. So in the next release, we might have the feature that we can schedule the application into different clusters. That's also different KubeVela core shards. Then it can reconcile in different Kubernetes etcd and API server. I think it can largely reduce the pressure.
Thank you, Jinbo. Just one follow-up question. You mentioned about latency. Does that the average latency does that show up in the Vela dashboard?
Yes, you can. Yes, the Vela dashboard will show the latency and lots of other information. You can check that.
All right, perfect. Thank you.
So, what happens if site-specific control restarted? You mentioned there is something which you store in memory. Does it lose any data?
Yeah, so the control plan, by saying control plan, you mean the KubeVela's controller or the Kubernetes API server?
KubeVela controller.
The KubeVela controller. Okay, so the simple restart of KubeVela controller will actually do not have any damage to existing application because those applications are stored in the etcd. So as if so when the etcd is not crashed, even if the Kubernetes API server is crashed, you can also make recovery for that. You just need to set up the application controller again. But in the real case that we have seen that usually the application controller crash, there are two major reasons. One reason is that there is some potential bugs in the application controller, and these bugs might caused by some special incorrect application configuration, but it is not rejected by the webhook. So it goes inside the etcd and the application controller watched it and it managed it and it crashed. So in this case, the restart of the application controller will also watch that bad application and crash again. And another very common case is that there is too much application in the system, so the application controller triggered the out of memory errors. So in that case, the restart of controller also cannot recover. So if the controller crashed because of other reasons, for example, the node that's running the controller is removed and it needs to be rescheduled to other node, I think the restart of controller will be okay to keep handling. Yeah.
So one more thing, you mentioned about round robin, right? So your controller, the master controller, uses for round robin, is it?
You mean the master controller use the round robin algorithm to schedule the applications. To be precisely, it's not the controller, but the webhook to do that things. But the webhook by default is installed with the master controller together in one container image. Yeah.
So you mean when there is a master shard is in weird state, still the applications works, this sharding and other things, or it's mainly depend on the master, so it has to be run all the time.
Yeah, so the when the master is broken, I think so. The default installation is that because we use the mutating webhook configuration installed in the Kubernetes system, so all the mutating of application will call the mutating webhook. So when the master container is done, so no mutating of application will be accepted because the webhook is done. But there is another case, is that you do not install the mutating webhook and you have customized scheduling rules. For example, you have a background operator that continuously watch application and assign the shard ID labels for it. And you do not use the mutating webhook. In that case, the master controller's crash will only cause the application in that shard that are not going to be handled, but the other shard will also keep okay. Yeah.
Okay, thank you. Is there a new, I think I understand this is just released. Based on the hotspot, let's say if you have a 10 swords, depending on the application size, what you mentioned, right? One of the sword could be getting a lot of memory, memory consumption. Can the controller dynamically transfer some application to different controller so that it can relieve that pressure, whatever it's saying, either it be memory or it would be a CPU?
Yeah, so I think the memory will be reduced quickly, and also the CPU will also have the reduction, but it will be not that significant. Yeah, because usually the CPU will have high pressure if it's running, so the average CPU use will going down gradually.
So what my ask here is, let's say what you said, like let's say if one of the sword is not working in weird state, you asking KubeVela client to move that application to the different sword. Could it be automated that rather than we do it intervening that situation? If the master or some controller detects some sword is not working, can we transfer the applications which is running on the, let's say the sword one is in weird state, to the other controllers? Is that a option?
Yeah, so currently we do not have that existing solution, but the design doc we have like foresee this case, and I think it will be a good case to for some background scheduler to do that thing, because if you have some customized scheduling rules, you can let it to watch for those applications that are assigned to the shards that are not working and reschedule them automatically. But I think the default strategy for KubeVela will currently I think we will do not do that for the user by far. But if we have lots of users that have the same idea that the scheduler should do these kind of things, then I think we can add something to the Vela core in the future.
Good, thank you. The reason I'm asking, most of the operators in production cluster, the developers doesn't have access, and it's like an extra learning for them to do this when this happens. But if you automate something that like they don't need to worry about this issue.
Yeah, so for most users, I think they should not need to worry too much about it.
I think there's some misunderstanding that we don't need to force anyone to use a client solution, that because mutating webhook is also not a stateless component. So we can just scale up that mutating webhook, and the scheduling job can also be done with no effect to the user, right, Inda?
Yeah, you can just disable the webhook and make customized scheduling rules for that.
Thank you.
And you can also scale up the webhook and to let it handle the more concurrent request. But the webhook itself is not able to make customized. For example, it's now use round robin algorithm to make scheduling. And if you want to make some like weighted scheduling, I think it's not possible for the webhook for now. But if you use some customized scheduling operator in background, and that will be okay with that.
Yes.
Okay, thank you.
Okay, if there is no more questions or you have any questions that you would like to ask in the future, you can just leave message on the Slack channel or on the GitHub issue as well. And thanks everyone for coming into today's community meeting. And okay, so that's the end for the community meeting today. Thanks all. See you 2 weeks later. Goodbye.
Bye-bye.
Thank you.
Thank you.
Thanks for staying up so late.
Bye.
Goodbye.